make it through. Alright, for the standard is on using transformations to graph absolute value functions. And then the 4 is finding the value of the transformation given the graph, so like doing the backwards part of it. This might be one of the most important standards in this unit. The reason it is so important is because what we learn here, we use every unit from now on. This is one of the shortcut methods I talked about with graphing functions, since so many functions follow the same pattern. So, if you don't know what the word transformations means in this case, that's kind of what we're going to touch and base on here. So we're going to go to the graphing calculator. And we're going to start with a function that you're comfortable with, which is a quadratic. So I'm just going to graph a normal quadratic in a normal window. Looks like that. And then we're going to see what happens to that original graph when we start playing around with it by adding and subtracting values. So I'm going to go ahead and add 4 to the function, and then we're just going to observe to see what happens. Okay, so when I added 4 to the function, it appears that the original function shifted up 4 units. If we go back, what happens if I subtract 2? Well, if it follows the same pattern, then hopefully it has descended 2 instead of shifted up 2. And it did that. Okay. So, one observation we can make is that when you add and subtract values from the function in question, that it shifts it up or down. Okay. Now, instead of adding and subtracting from the function, we're going to actually add and subtract within the function and then see what happens. So I'm going to subtract 2 from x. There's my original. Okay, so it looked like by subtracting 2 from x, it actually shifted my graph to the right 2 units. So let's go ahead and maybe add 3. If it follows the same pattern, then it should go to the left 3. Let's see if that happens. And it did. Okay, so an observation we can make there is when you add or subtract values from your x in a function, it shifts it left or right, which makes sense because x is your horizontal axis. So if that's changing, then it's going to change in a horizontal way. All right, what if we made a negative? There's the original. Okay, so by throwing in a negative in front of the function or by multiplying by a negative, it looks like it flips the entire graph upside down. All right, and then one other thing that we have to check here. Whoops. I'm just taping notes, so I'll be talking while you're working. Okay. And then we're going to be looking at one other place where if you multiply by a factor, in this case we're going to be multiplying by 3. Let's see what happens with the graph. Okay, so it looks like by multiplying by a factor, it's making the graph skinnier. So let's say to multiply by 3, we multiplied by 1/2. Now let's see what happens. If it follows the same pattern, instead of being skinnier, it should be a little bit fatter, which actually it does end up doing there. Okay, so I'm going to zoom out now. And this I wrote out in the first video, and then I had to redo it. So it might be a good idea to pause this, but I'm going to quickly talk through it. So these are the observations we made. When we added numbers to the function or subtracted numbers, the graph shifted up or down. When we added or subtracted numbers with the x in the function, it went left or right. When we attached a negative, it made my graph flip. And when I multiplied by a value, it made the graph skinny or fat. So all 4 of those things are what we call the transformations, or the numbers that you would attach to a general function, which in this case was x squared, to make the graph look different. Alright, now we're going to obviously practice with this a little bit more, but to get some notes down, examples, we are focusing on transformations as it affects absolute value functions. So let's go ahead and write the general absolute value function. You will see this kind of setup over and over and over again depending on the function. With absolute values, we know it's an absolute value function because what's affecting the x is absolute value bars. We know that this is a quadratic because what's affecting the x is a square. So the function on x is being squared. So you'll see that, like for this, we can write a quadratic that looks like that. And with absolute value, we have the kind of the same setup. The only thing that changes is the function on x. So the h and the k do some things to my graph. And the steps to graphing that we usually start with, always, is to label the transformation. Okay, when you label the transformations, the only ones I care about with graphing are labeling what direction it goes left and right and what direction it goes up or down. The making it skinny and making the graph flip, that's taken care of actually by something we do in step 3. So when I say label transformations, I just want to see if it goes left, right, up, or down. H moves your graph left or right. K moves your graph down or up. So we usually label that with arrows and then go on from there. The next thing we do is make a small table of values. Now, depending on the function, some x's are easier to plug in than others. In this case, we're going to use 3 easy ones, -1, 0, 1. Okay. Once you find your small table of values, you're going to plot your points. And then we shift. Whatever direction it's supposed to go. So you plot your points and then you shift. And then you draw in the graph. And we're going to do some work with domain and range. So determine the domain and range. Okay. Now, one key thing that you have to pay attention to here is the h value is what moves it left or right. So if you have x minus 3, h is positive 3. If you have x plus 3, h is actually negative 3, because to write it in this form, you'd have to write it as x minus a negative 3. Okay, that's going to come into play with this shifting thing. All right, go ahead and flip. We're going to do these 2 examples together. And then the next or last page of our notes is the 4 type problems for that, so we'll cover those probably tomorrow. All right, for example 1, we have y equals 2 times the absolute value of x minus 1 plus 3. Okay, the first thing that we do is label the transformation. So I usually ask the question, how does this 1 make my graph move? Well, this 1 is actually the value of h here, and since it's x minus 1, then my h value is positive 1, which means it's going to move to the right 1. So I draw a little arrow to the right, and then write a 1 there so I know how many units to go. And then your k value is what moves it up or down, which is what we have right here. So that means we're going to move up 3. Now, I know that 2 is going to make my graph skinnier from what I did on the calculator before, but I don't have to label that transformation here because my small table of values that I'm going to make next actually do that for me. Now, a couple years ago, I had a student say, you know, when I graph, I actually draw brackets around the y and the x so that when I plug in my values, I remember which part to plug it in. When we plug in these values, we're only plugging it into that section of the function here, because the 1 and the 3 we've taken care of in terms of the arrows. The reason we do it this way is because we can easily plug in -1 here and figure out what these y values are in our head without having to do a bunch of other adding and subtracting here. Okay, so when I plug in -1, you have to perform the function on x. So what is the absolute value of -1? Well, the absolute value of -1 is 1. 1 times 2 is 2. When you plug in 0, the absolute value of 0 is 0. 0 times 2 is 0. Plug in 1, the absolute value of 1 is 1. 1 times 2 is 2. Then we're going to plot those 3 points. And when I plot them, I usually use little X's so that I remember or recognize that those are my original points, but they aren't the real points of my graph because I actually have to shift them. So we're going to shift each one of those points right 1 and up 3. And then let's talk about what the shape of an absolute value is. Absolute value functions are like lines that have been cut off at the x-axis, and this part has been made positive, so it like flips up above. So if we made this part positive and flipped it up above, it would have a V-type shape, because the absolute value, you're assuming that the whole graph is positive. So we're going to go ahead and graph that in as a V. So it's not a parabola, it's not a quadratic function, but so it's a V shape instead of a U shape. There's a sharp turn there. Okay, now let's talk about domain and range. Domain in this case is all reals. You can plug in negatives, you can plug in positives, you can plug in 0, and it works. The range here is actually based on the graph. So once you determine what your graph is, you look at where your graph ends. Well, your graph ends at the y value of 3 and then goes up from there. So your range is going to be y values greater than or equal to 3, because remember, range is the y values that exist on your graph. So that's anything above 3. Okay, let's do one more together. All right. Again, we're going to label the transformations. This 2 is actually going to make my graph move left 2, because technically this is x minus a -2, and it's that h value that moves it left or right. So we're going to move left 2. And then this -4, is going to make my graph go down 4. And then we're going to do our small table of values. I draw brackets. And then you plug them in. So when I plug in -1, the absolute value of -1 is 1. 1 times -3 is -3. When you plug in 0, absolute value of 0 is 0. 0 times -3 is 0. Plug in 1, absolute value of 1 is 1. 1 times -3 is -3. We're going to go ahead and plot those 3 points. And then we're going to take each one of those points, shift them left 2 and down 4. And then you can draw on your graph. Alright, now let's talk about domain and range again. And the reason we talk about domain and range so often with graphing is because in this case it's just working on your basic skills and building up your basic skills. But when we actually have to apply this, you have to be able to determine, is this x value going to work or is it not? And if I'm looking for a particular y value, is it even possible? Especially if you're working with a real life scenario, you got to know what your domain and range are, usually. Alright, your domain for absolute value, again, you can plug in anything you want, and it works, so we're going to say all real numbers. And then your range is based on where this graph stops. So this graph stops at the y value of -4 and goes down from there. So your range is going to be y values that are less than or equal to -4. Okay, now I know that was a quick little video. I was trying to keep it to 15 minutes, which is exactly. We're definitely have more practice on this tomorrow. Everyone needs to be very well versed in this graphing method since we use it so much. So we're going to have lots of practice tomorrow. But we've done